And now I'm going to take this coil, I'm going to put it so that I'm going to fill this with water. So there's water here. So I have water in here. I'm going to assume that we have 2 kilograms of water. Now, let's say originally the water was at the temperature, which is 20 degrees Celsius. So what I want to do is that I want to heat up this water. So I want to heat the water up. So heat up water. So heat up water such that it's going to boil. And we know that a boiling temperature of water is 100 degrees Celsius. Now, this is given in the problem, so this is given. So let's assume that it takes 4,200 joules of energy so you need 4,200 joules of energy to raise the temperature of 1 kilogram of water by 1 degree Celsius. So what we need to do is that we need to calculate how much amount of energy do we need. So part A here, how much amount of energy do I need to take 2 kilograms of water? So let's multiply. So if you take 4,200 joules a kilogram degrees Celsius. So you want to multiply this by 2 kilograms of water. And then you also want to multiply this by 80 degrees Celsius. Now, do you guys see where the 80 degrees Celsius come from? It's a change in temperature as you go from 0 to 100. Now, do you see that this calculation makes sense because the kilogram is going to cancel with the kilogram and the degree Celsius is going to cancel with the degree Celsius. So what do we end up with? We end up with something that is just going to be joules. That's an energy, right? So let's punch that on the calculator and see what we're going to get. So we multiply 4,200 by 2, and then we multiply this by 80. So this is, so let's write this as, so this number is equals to 672 0 0 0 joules. The question is that how long is it going to take for that water to boil? Assuming that you have a heater that is supplying, so this heater has a resistance of 8.0 ohms and is connected to a battery that delivers 120 volts, right? So what we can do is that we can calculate, the current. So remember that we can calculate, so let's say the electrical current. So I can calculate my current. So we know that resistance is voltage over current. So current is equals to now, if you substitute that, what do we get? So that would just be 120 divided by 8. So 120 divided by 8. So that gives me a current of 15 amps. Now let's calculate, sorry, this should be part B. let's calculate the power. So how much amount of power? So this power is so this is called the power output. So this power output of the heater is given by P is equals I squared times R. So if you take 15, you raise it to the power of 2. So it's 15 times, and then you want to multiply that by the resistance, which is 8. So this will give you joules per second. So if my heater is supplying 1800 joules for every second, how long is it going to take for me to go up to supply 672,000 joules of energy? I can do that calculation, right? So you say, so for part E, so for part B, you just say power times time must be equals to 672,000. And so if you solve that equation, you can get your time. So your time, so solving this equation, you just get your time. It's going to be equals to this number divided by 1800. So this would be about 373 seconds, which so this is about like close to 6 minutes. So do you see that? How long is it going to take me to heat up my water from 20 degrees Celsius to 100 degrees Celsius? It simply depends on how much amount of voltage we have and what is the resistance of the, do you guys see that? Because the supply voltage and the resistance of the heater tells me what the power output of my heater is, right? Now, this same type of problem here, you can also apply this to something like a microwave oven. So if you look at microwave ovens, each of those have different power outputs. So sometimes you put a cup of coffee there, right? It takes no time to raise the temperature of the coffee. So if you look at the microwave oven very well, it tells you what the power output is, right? So sometimes it could be like maybe 80 watts, 120 watts, 200 watts. So that tells you what the amount of energy. So for example, let me just open. So if you look at a microwave, so this is basically the same type of principle, but each of these has a power output. So for example, you could see something like 120 watts. This means that it's supplying 120 joules of heat for every second. It could be 200 watts, 200 joules per second, or maybe 400 watts. So you could look up this number. Because if you have a very, very high power microwave, right, that tells me that I'm getting more output energy. But again, remember that high power means that it's going to consume more electrical current and more energy. Right? So again, there's a trade-off. You can raise the temperature a little bit faster, but then this is going to show up in the utility bills, right? So more current is going to be used in the All right, is there any questions about this? Okay, so let me go back to I think we're almost about to wrap up this chapter. So let me just go back to my. All right. So I think this example number 24 point. So I think this example was pretty straightforward, right? So you just calculate, so you calculate the current. Then once you know the current, you can calculate the output energy. Let's look at the next example here. So the second example, okay, I think I'm going to skip. So let's look at this example right here. I think this is almost very similar to the problem that we just solved. Now, I'm going to give you maybe like a couple of seconds here. I want you guys to just read the problem very carefully. But what this is saying is that you have some electrical heater. And we have a mass of water that is 1.5 kilograms. And we want to raise the temperature from 10 degrees Celsius to 50 degrees Celsius. And the time that it takes for this to be accomplished is 10 minutes. While this is operating at 110 volts. Now, in this problem here, the main thing is to understand, so this value here is that value that I just gave you. So I gave you this as 4,200 because I just rounded that up, but this is the amount of energy here. So 4,186 joules per kilogram. So this is how much amount of energy, right? So I need 4,186 joules to raise the temperature of 1 kilogram of water by 1 degree Celsius. So it means that we need to take this quantity and multiply by the mass. So the mass is 1.5. And then we also multiply this by the change in temperature. So the change in temperature here, delta T, is 40 degrees Celsius. Now, if you see all of this quantity here at the bottom, so all what you have here at the bottom is just what I'm talking about. So you take this quantity, and you just multiply by the mass, and you multiply that by the change in temperature. So all of that should give you the total amount of energy that you need to raise the temperature of water.
Would we be given C, 4186?
Yes, yeah.
C is a constant? Or
Yeah, so C is this value here. It's called the specific heat. This is called the specific heat capacity. For water. Right, so if I gave you something like this, if I'm going to give something like this in the exam, I'll give you those values. So again, if you look at this equation, if you rearrange this equation, we're just saying that, for example, so delta T times delta V squared over R must be equal to Q. Now Q is this total energy that we've just calculated here. My delta T is my 10 minutes, which is 600 seconds. And delta V is the voltage, and then you want to solve for the resistance. So if you just rearrange those equations together, you end up with this value. And finally, it says that estimate the cost of heating the water.